to this video on simulating multi-site gateway cloning with Genius Prime. Multi-site gateway cloning lets you clone multiple DNA fragments into a single expression clone. Please refer to the gateway cloning tutorial for single fragment cloning. As with standard gateway cloning, the first step starts with the BP reaction. In this case, you create multiple DNA fragments of interest containing flanking ATB sites. The ATB sites on each DNA fragment must be oriented correctly and compatible with adjacent inserts. For example, in a 3-fragment multi-site gateway cloning experiment, the first and third DNA fragments should contain ATB sites oriented inwards. The middle fragment should have ATB sites that are oriented outwards. The adjacent fragments should also contain the same ATB sites. In this example, the first fragment has a 3' ATB4 site, and the second has a 5' ATB4 site, while the second fragment has a 3' ATB3 site, and the third has a 5' ATB3 site. Refer to the table on the Genius website to ensure you select the correct ATB sites for your simulation. These DNA fragments will recombine with suitable donor vectors during the BP reaction, resulting in individual entry clones. The compatible flanking sequences of these 3 entry clones recombine during the LR reaction and are incorporated into the desired destination vector. The result is a final expression clone containing the multiple DNA fragments of interest. That's a brief overview of multi-site gateway cloning. Let's now simulate this process in Genius. To start, we will design primer pairs that will add ATB sites to every DNA fragment of interest. We will use a 3-fragment simulation for this example, but the steps are similar for reactions with different numbers of fragments. For the first fragment, click and drag to highlight a region of interest you want to clone, or simply select an annotation on the sequence. Then select Primers and choose Design New Primers. In the Design New Primers window, select Design New and set the task to Precise. Tick the Included Region option to populate the region values based on your selected regions of interest. Also, you can specify how many primer pairs you want Genius to design. A value of 1 will create a single primer pair. You can expand the characteristics options below to fine-tune your desired primer pair characteristics. For example, you can adjust your target primer size, melting temperature, and GC content. To add the 5' ATB sites to the primers, select the Advanced option at the bottom and start with the forward primer. Select the Gateway Site button to see the available ATB sites to add for gateway cloning. Then, use the drop-down menu and choose the appropriate ATB site for your experiment. Remember to refer to the table from the Gateway Cloning tutorial page on the Genius website to ensure you select the correct ATB site. In the preview window, you can see that 4 guanine nucleotides will be upstream from the ATB site, ensuring the clonase enzyme binds efficiently to the terminal ATB site during cloning. Simply repeat this process for the reverse primer. Again, select Gateway Site and ensure you select the appropriate ATB site for your reverse primer in the first DNA fragment. When you're happy with the primer settings, click OK to add the forward and reverse primers to your sequence. Before proceeding, make sure you save your file by selecting Save or use the keyboard shortcut. With the primers designed, the next step is to simulate a PCR to extract the region flanked by the new primers. Select Primers and choose Extract PCR Product. Then use the drop-down menus to select the primers you recently designed, and click OK. This will create a new sequence file containing the PCR product flanked by the 2 ATB sites. It's then a case of repeating the primer design process and PCR simulations for your other DNA fragments. Again, remember to ensure you select the correct ATB sites for each fragment. Next, use the various PCR products and perform separate BP clonase reactions with appropriate donor vectors. Since each PCR product contains unique ATP sites, you must select a donor vector containing compatible ATP sites. For example, if the PCR product contains the ATP1 and ATP4 sites, the donor vector should have the ATP1 and ATP4 sites. Select both the compatible PCR product and donor vector files to simulate the BP reaction. Then go to Cloning at the top and choose Gateway Cloning. Genius will notify you of the files in the BP reaction simulation. Simply click OK to confirm. The resulting entry clone file containing your first PCR product should be visible. Repeat the BP reaction simulations for your other PCR products, remembering to ensure each donor vector contains the appropriate ATP sites. You now have multiple entry clones ready for the final LR reaction. Use these to create your expression clone. For the LR reaction, you will also need a destination vector. The destination vector should contain AT-R sites compatible with the first and last AT-L sites in your entry clone sequence. For example, if your first entry clone begins with an AT-L1 site and your last entry clone finishes with an AT-L2 site, the destination vector must contain the AT-R1 and AT-R2 sites. This compatibility ensures the entry clones recombine in the correct order and orientation. To simulate the LR reaction in Genius, select all your entry clone sequence files and the appropriate destination vector file. Then select Cloning and choose the Gateway Cloning option. Genius will notify you of the files entered into the LR reaction. Simply press OK to perform the simulation. The final result is an expression clone file containing the multiple DNA fragments of interest. Visit genius.com for more hands-on exercises and tutorials.